Okay, so ratio and proportions, that is what we're going over today. First things first is the ratio part. So, ratios and proportions. First things first, ratio. Do we know what a ratio is? Does anyone know what a ratio is? No? You guys are here for me to tell you? What? So here we have a word problem. A softball pitcher strikes out 4 batters for every 1 batter that she walks. What is the ratio of strikeouts to walks? All right. A ratio is pretty simple. All it is a way of writing some numbers. It's a way to write out a form of what's written. So a softball pitcher strikes out 4 batters for every 1 batter that she walks. And they ask, pretty much ratios is really important that you guys always look at the last question. What is the ratio of strikeouts to walks? So they want to know the ratio of strikeouts to walks. Well, the first thing you need to know is how ratios are written. There are 4 ways a ratio is written. All right. So here they say a ratio, what is the ratio of strikeouts to walks? Well, tell me, you guys, what is the strikeouts? A softball pitcher strikes out 4 batters for every 1 batter that she walks. So technically, it's 4 to 1, right? Well, that's one way of writing out a, oh, geez. It happened in the first class. The pen is starting to give out. You can't write anymore.
Well, it was free, so.
Yeah, I know. So the first way you could write out the ratio is 4 to 1. Literally, ratios could be written 4 to 1, right? Another form, a common one that you'll see, and those of you taking your GED will see it on the test, is 4 1. 4:1. That is a ratio right there, 4 to 1. And then the even more common one, 4/1, right? So, that's all ratios is. That's all it is. All right, boom, done. Go take your GEDs. Those of you that are in my class for the ABE, take your final exam right now. No. So, it's important, like I said, to always look at the final question. Because if the final question were to say, another new student. Nice. Nice to meet you. No, you can go sit. It's cool. If the question were to say, what is the ratio of walks to strikeouts? Like how my line went down. If it says walks to strikeouts, what is the ratio? 1 to 4. So all of this flips. It's 1 to 4. 1:4 and 1 over, 4. Right? So it's always important to look at the final question of what exactly they're asking for. So that we get the overall idea of what ratios are, right? Well, how about we do another example? So Frank manages a small drugstore. During a 2-hour period, he counts 25 cash sales and 15 credit card sales. What is the ratio of credit card to cash sales? So what's my ratio? So we're going to be dealing a lot with fractions, because obviously we just went over fractions, right? So majority of the worksheets and what we deal with from here on out, our ratios are going to be written in fraction form. All right? So it's 15 over 25, right? Good. because you guys didn't fall for the trick. Usually students just see 25 first, then they see 15, and then they just put 25 over 15, right? Or 25 to 15. And like I said, it always comes down to the last question. But now, what must you do? Yeah. Yep. So last week, if you remember, we went over the fraction basics, such as simplifying fractions. You must, with ratios, always simplify your answer. So what could we do here to make it simpler? What is the equivalent fraction of 15 over 25? Well, if we remember, what we like to do is divide, right? And for those of you that are beginning with simplifying, a lot of people like to divide straight to the 2. They just love the 2 trick. But if you recall from last week, look at those. Those have 5s, right? 5 is one of those unique numbers in which all it's divisible by is...
5.
Yes, a 5 is only divisible by 5. 25, 15, they could be divisible by... Or 15 could be divisible by 3, right? But 20, when you see 5s, your immediate reaction should be, I'm just going to go straight to the biggest number, the 5. Let me divide by the 5. So we simplify. What is 15 divided by 5? What is 25 divided by 5? It's 3 over 5. That's the final answer. You must always simplify if you can. So the final ratio of this word problem is 3 over 5. Pretty simple, right? Ratios are pretty simple so far. So now comes another ratio problem. I'm pretty sure we already have it, because I do want to go over proportions a lot. Somebody trying to come in?
Yes.
You kicked my thing. Hey, come on in. So here we have another ratio problem. A football team won 12 games and lost 8. There were no tied games. What is the ratio of games won to games played? So, the reason why I'm showing you this example is because it is important to know that math is always trying to trick you, right? It's always trying to make you critically think. So, sometimes just to find a ratio, you have to do an extra step before writing out your final ratio. So, and it always comes down to, again, the last question. The last part of the question. So, a football team won 12 games and lost 8. There were no tied games. What is the ratio of games won to games played? So what are they looking for? They're looking to wins. They're looking for wins to games played, aka total games, right? So, but if you notice, they gave us our winning games, which was 12, right? But then they give us this, our 8 lost games. A lot of people would just put 12 over 8, right? It's a habit. They see numbers and they assume, oh, I'm just going to put it, right? But that's not the case. What do we got to do? We have to add the 12 and the 8 to create what?
20.
So yes, this is proof, or this is an example of you guys are going to have to do some extra steps sometimes leading up to writing out your final ratio, right? If they were to say, what is the ratio of games won to games lost? Yeah, easy, 12 over 8, right? But keep an eye out on these trickeries. Keep an eye out on the question always, If it says games played, that means the total games. So, that's all you need to know about ratios. Any questions on ratios? Any questions? No? Whatever. So now comes proportions. Who here knows what proportions are? Nobody? Before we go to that example, let me explain what proportions are. So, I love doing this. Ugh. My pen is messed up, so that's why it's bad drawing. But I'm actually a good, sure, I'm actually a good drawer. So, here's a typical proportion problem, all right? The question goes like this. Engineer is building a little miniature scale model of the new 2019 Lamborghini. And this is it, right? He designs it perfectly to the way the real car has to be. And he pushes it to his company. The company gives it an okay. They say, let's build it exactly the way it is. So what do? They upscale it into the real car. Into the real car. And so they do pretty much went from this miniature scale model to the actual car, right? And then the question is like this. If the new height, if the height of the miniature scale Lamborghini was 3 inches and the length of the miniature scale model was 7 inches and the new length of the car is 6 feet. The question is, what is the height of the new car, of the scaled car? So, this is a traditional proportion problem. Find the missing number when given one whole ratio, 3:7, and given a piece of the other ratio. This is a traditional proportion problem. So, how do you solve proportions now? Well, the thing is, what we got to do, the hardest part with proportions is setting it up as a proportion problem. So this is what I mean. Proportion problems must be set up like this. The first ratio that's given, they'll give you one whole ratio no matter what. In this case, my 3:7, right? What does my 3 represent? This 3 represents my height. What about the 7? The length, right? So you've identified that this row, the top row, the numerators are going to be my height, and the bottom is going to be my length, right? So you must set it up like this. 3/7 equals, I should have done that. Where should my 6 go? Where should I put my 6? Where you have it. I jumped the gun. You guys should have known to put the 6 below, right? Because the bottom section is the length section, right? And what I'm looking for is my x, my missing number, my height, the height of the actual car. This right here is what you guys have to do all the time. Set it up like this always. Because now we get to do something. Does anyone know what we're going to do?
Cross multiply?
Yeah. Cross multiply and then divide. So what you're always looking for is the numbers that have, the cross fractions that have numbers across from each other, right? For example, the 7 and an x, that can't be done. Why? Because one is a number and one isn't, right? So you can't look at that. Always look for the numbers that have something across from each other. And what you're going to do is multiply those numbers. You multiply 3 times 6. What's 3 times 6? Okay, it's 18. That number, you must now get it and divide by your last remaining number, wherever it's at. You then divide it by the last remaining number. So what's 18 divided by 7? Well, you guys could take out a calculator or freshen up your skills and divide by hand. Fits in 2 times to create 14. Let me move it up as far as I can. Whatever. 14, which gets me 4, a remainder of 4. I could then create a decimal, create a 0, bring it down. How many times does 6 fit into 40?
6 or 7.
Creating 6 times 6? Oops, sorry. Sorry. Blame the pen. How many times does 6 fit into 40? Sorry, I just can't. I can't. I need space. I need space, you guys. Sorry. So I had a 2 here. I created the decimal. 5. It is 6. 6 times 6 is 36. Oh, you're right. Let me erase that 6.
That's why I was like 6 or 7.
Sorry about that. Okay, 5 times 7. Creating
35.
You guys are complicating my life again. Once again, I'm blaming you guys. 5, 10, 50, 20, 25, 30, 35, 40. Oh yeah. Leaving 5, right? I just got to move it up, that's all. And you could stop there, but if you wanted to continue, you just bring down another 0 and then do the same cycle. How many times does 7 fit into 50? Yeah, but most of the time, up until the 10th place is fine, right? So if you want to round it up to 2, you want to leave it at 2.5, it's fine, or 2.6, whatever. But pretty much your x, the missing piece that's right here, is 2.5. We're going to round it up to 2.6 for right now. So does that look right, first of all? Do you feel comfortable with that answer? The height of the new car is 2.5 feet high. Well, yes, because if you notice, my first ratio, 3/7, right? If the second ratio has a 6 for its length, I already know that the height should be lower than the 3. Obviously, this first ratio is in inches, right? And the second fraction, the second ratio is in feet, but that's not the problem. Don't ever worry about the units. They'll tell you the units of feet or inches or whatever. What we're looking for is the raw number. Is this proportional to each other? 3/7 equals 2.6/6. Does it look correct? Yes, it does. Because it is. So, going back to the actual word problem, a map scale says that 2 inches equals 150 miles. What actual distance would a map distance of 5 inches represent? So, how do we solve proportions? I must first write out my ratio that's given. What's the first ratio that's given? 2 to what? Oh my goodness gracious. I'm just going to have to use my fingers. So for every 2 inches, it's 150 miles, right? So this map, little scale says 2 inches on this map in real life is 150 miles. That's the first ratio that's given. The 2 representing what? Inches. And the 150 representing what? Miles. So this whole top row is inches, the bottom row is miles. So where should my 5 go? Because that's what they're looking for. What actual distance would a map distance of 5 inches represent? Where should the 5 go? Up top, because obviously it even said it, 5 inches, right? So I want to look for the actual miles in real life this map is depicting. So you do the same thing. You look for the numbers that have something across from each other, in this case the 5 and the 150, and you multiply them. So what is 150 times 5? And then 150 times 5? 750. That number you then divide always by the remaining number, right? So then, again, you guys will be able to use the calculator here. So you do 750 divided by 2. How many times does 2 fit into 7? We're doing it step by step. How many times does 2 fit into 15? How many times does 2 fit into 10? Creating 10 exactly with the remainder of 0 and 375. So 5 inches on this map is 375 miles in real life. So those are the type of proportion word problems that's going to be given. Always find the missing piece. Any questions on proportions? No questions on proportions. What about ratios? Nothing. Do you know what we're going to do now? Yes. We're going to test your knowledge and skills with everything I just did. And we're going to do some worksheets.